Many people are either new to programming in Python or they've learned how to code in other languages like Java and C, and so they use constructs from these languages in Python. Now, that's usually because they aren't aware of some key features that are available in Python right out of the box. This course is designed in layers, so if you have a good basic knowledge of Python, you'll learn a lot. So apart from learning how to use several of Python's built-in functions, you'll learn how tuple ordering works, how to work with iterables and sequences and classes, and how to refactor code so it's more Pythonic. Now, even if you're an intermediate or advanced Python programmer, you'll probably pick up a couple of tips and tricks. Python has a built-in function called all that returns true if all the items are true or truthy. This means they are non-empty or non-zero. Let's head over to the exercise folder. So I just head over into the Python REPL. Let me just give myself a little bit more space. So if I have a list with strings, and I use the all function, you can see that this returns a true. If I change any of those strings to an empty string, this returns a false. So go ahead and grab the all.py file from your exercise folder. So the valid_RGB function will receive an RGB tuple, so that's red, green, and blue. And if you have worked with colors before, you'll know that they have to be integers between 0 and 255 inclusive. If they are, the function returns true, otherwise it returns a false. Now, we'll keep things simple and only work with integer values here. So if we wanted to use all in the valid RGB function, we'll need an iterable to pass to all. Now, an iterable is anything you can loop over using a for loop. Examples include lists, tuples, strings, sets, and dictionaries. So we could transform our for loop into a list comprehension, and let's call that valid. So I'm going to keep a copy of the valid RGB at the top just so that you have that for comparison. And let's create our list comprehension. So valid equals, and let's think a little bit about the condition. We want to check if all of the RGB values are between 0 and 255 inclusive, and accordingly either return a true or a false. So let's just grab the condition here. And you'll notice we don't need the if statement, the no condition, or the colon, and we can reuse the for loop. And I can get rid of everything else. And we return all and the valid list. Now let's just make sure this works in our REPL. And I'm going to just run a couple of tests on this. So this passed all of the tests. Now it seems odd to create the list valid only to loop over it once. We could also use a generator instead. Now, all returns a true if all of the elements of the iterable are true, and all you need to do to change the list comprehension to a generator is to swap out the square brackets for parentheses. Now, if you look at our code, you'll see that we don't even reference valid anywhere else. So let's get rid of that, and let's just rewrite this as removing the valid, so we'll return all of this, the entire generator, and let's just make sure this passes all of our tests. So I'm just going to clear my screen and the REPL, and let's just paste this into the REPL, and let's run our tests on this. So here's one way to think about using the all function. You have the all function call, you have the condition for the items in the iterable, and finally, using a for loop, you loop through the iterables. And that is Python's all function. Python has a built-in function any that returns true if any of the items are true or truthy. This means they are non-empty or non-zero. Let's take a look at a couple of examples in the REPL. Now I need to pass in an iterable to the any function. So let's use a tuple. So we have any and our tuple. Now let me use a string and an empty string. And we get a true as one of the strings are non-empty or non-zero. Now if we replace the string with a 0, we get a false. And this is because now we don't have any true or truly items in our tuple. Now go ahead and grab the any.py file. And this function will check to see if the input string contains a digit. And we've got a couple of tests below the function. So let's check this works in our REPL. So I'm just going to copy across the function and the tests. And I'm going to paste them across in my REPL. And you can see that it's passed all of the tests. So let's see how we could use the any function. Like with the all syntax we covered in the previous video, you have the any function, you have the condition for the items in the iterable, and finally, a for loop that you loop through the iterable. So let's head back to our code. Now let me make a copy of the code below so that you can compare the two. And now let's refactor this using the any function. So the first thing we want to do is we want to return the condition. So return any, and let's grab the condition from here. And we don't want the colon. The next thing we want is the for loop. And I get rid of the colon at the end, and we're done. So let's copy this across to the REPL. And let's test our new function. And you can see that it's passed all of the tests. So that looks good. And that is Python's any function. In this challenge, create the function contains punctuation that takes in an input string and returns true if the string contains a punctuation and false if it doesn't. Let's define a punctuation from the string module. So let me head over to the REPL. So I'm going to import string. And let's define a punctuation as the following. Now you can use the test file in the test directory to check your solution if you want, or you can ignore it completely. Now if you're new to PyTest, you'll need to have this package installed. So just do a pip install PyTest. We'll use the test file to test your solution against a couple of sentences. Let's look at the tests in the test any all challenge file. You'll find this in the test directory. You can see that we're using the test function that contains punctuation with different sentences. So some of the sentences have punctuations in them and others don't. So after you've completed your solution code in the any all challenge.py file, you can test it by doing a PyTest and the path to the test any all challenge file. So let me show you what I mean. So I'm just going to head out of the REPL. My current directory is the exercise file. So let me just clear my screen. And so I just do PyTest, challenge, tests, and then test any all. You can see that I've got the message 2 failed, and that's because I haven't created any code yet within the any all challenge.py file. So once you've created your solution, rerun the PyTest. And if you get the message 2 passed, then you're done. So go ahead and use the any all challenge.py file as your starting point. This challenge should take you about 5 minutes. In the challenge overview, we've already seen that the test any all challenge.py file contains some sentences with punctuations and others that don't have one. So let's go ahead and modify the any all challenge.py file. Now in this case, because we're looking to see if we can find a punctuations in the input string, we'll want to use the any function. So let me go ahead and replace this line. So return any. And we want to loop through each character of the input string. So for car in input string, and let's think a little bit about the condition. We want to check if the car is in string.punctuation. So car in string.punctuation. And that should be it. So let's go ahead and save this file and see if this passes all of the tests using PyTest. So my current directory is the exercise file. So I just do a PyTest, challenge, tests, and test any all challenge.py. Now from the output, you can see that this has passed all the tests. Now, if you have a slightly different solution that passed all the tests, then that's fine. You don't need to have an identical solution to my one. And that's the end of this challenge. Let's head over to our enumerate.py file. Now we've got a list of country names that are in decreasing order of the number of characters. That means the first country name in our list is the longest and so on. But we also want to print out a number at the start of each line. So number 1 means it's the longest, number 2 the second longest, and so on. The expected output is shown in the Python file. Now if you're new to Python, you might go for something as shown in the enumerate.py file. So let's run it in our REPL to make sure it works. So I'm going to just copy the countries list and the for loop. And let's head over to our REPL and let me give myself a little bit more space. And you can see that we get the expected output. Now you can also use Python's built-in enumerate function, which allows you to loop over a list and retrieve both the index and the value of each item in the list. Instead of having to start with an index of 0, which is the default, we can also start with 1. So for item in enumerate, we provide our list, which is countries, start equals 1, and we print our item. Now the enumerate function gives us an iterable where each element is a tuple that contains the index of the item and the original item value. So instead of using item, we can split it out into index and country. So for index, comma country in enumerate, we provide our countries list and start equals 1. And use the f string, so f, and in curly braces index, and then the country name. Now, of course, if you didn't need the numbers at the start of each line, we could easily have just gone with a regular for loop. So for country in countries, print country. So in conclusion, if you need to loop over an iterable and you need an item's index, use enumerate. If you only need to loop over an iterable and don't need the indices, then just a regular Python for loop will do the trick. And that is Python's enumerate function. Let's head over to our zip.py file. Here we've got a list of country names called countries. We also have a list of capital cities for each of the countries that corresponds to the countries list. So the first item in the capitals list is the capital city of the first item in the countries list, and so on. Let's create the expected output as shown in the zip.py file using these two lists. Now, whenever you want to loop over multiple lists or iterables at the same time, you'll want to use Python's zip function. So I'm going to copy across the two lists, and let's head over to the Python REPL. For country and capital in zip, and we use the two lists here, so countries, capitals, and let's use fprint. So the capital city of the country in curly braces is capital in curly braces. And you see we get the expected output. So the zip function makes an iterator that aggregates elements from each of the iterables. So for each of the iterables we've been working with, so that's the countries and the capitals list, we've had equal number of elements. If one of them had a fewer number of elements, then zip would stop after the shortest list runs out of items. Let's go ahead and demonstrate that. I'm going to remove Niamey and Tokyo from the capitals list. Now, I've already got a version of this in my zip.py file, so I'm just going to copy that across. And if you go ahead and rerun the for loop, you can see that it stops with Nepal for the countries and Kathmandu for the capitals. Now, what if we wanted to do something different from the standard zip functionality? So the countries list has more items than the capitals list. So if we wanted to work with all of the items in the countries, we'd need something for the missing values for the capitals so that we can use these when we've run out of items from the capitals list. Now, zip longest from the itertools module does exactly that. So let's import zip longest from itertools. Now, because capitals has fewer items than countries, we're going to need a fill value when we run out of items in the capitals list. So let's call this unknown. So I'm just going to modify our previous zip function and use that for zip longest. And we'll need to include a fill value. So fill value, and let's use unknown here. And I can reuse the print statement. And you can see that we have unknown values for the capitals of Niger and Japan. Now let me go ahead and copy across the complete capitals and countries list. And let me clear my REPL. And finally, let's look at unzipping a sequence. The first question you might have is, if there's a zip function, how come there's no unzip function? And the reason is we don't need it. Let's take a look at an example. Now, if we grab our countries and capitals list, let's create a list of tuples. So pairs is a list of zipping together the countries and capitals. Now, if we want to separate the elements of each tuple into independent sequences, let's call these country and capital. So country and capital equals zip. Now, when calling the zip function, the asterisk or the star operator can be used to unpack an iterable into the arguments in the function call. So we can unpack pairs. Now, the line zip star pairs is passing all of the items in the pairs list into the zip function call as separate arguments. So country then is a tuple with all of the country names, and capital is a tuple with all of the capital cities. And that is Python's zip function. In this challenge, you're given the births in England and Wales from 2010 to 2019. So the list year has all the years from 2010 to 2019. The list birth has all the births for the corresponding year. So you need to return a list of tuples where each tuple is the year, the birth, and the running average. So let's talk a little bit about what a running average is. So the running average of 2010 is how many births there are in 2010. The running average of 2011 is the average number of births in 2010 and 2011. And so on. You can use the test file in the test directory to check your solution if you want, or you can ignore it completely. To test your solution using PyTest, just do PyTest and then the path to the test zip enumerate challenge.py file. If your solution passes the test, you're done. So go ahead and use the zip enumerate challenge.py file as your starting point. This challenge should take you between 5 and 10 minutes. So let's go ahead and modify the zip enumerate underscore challenge.py file. Now, just to keep the names consistent for the list, I'm going to change the name year to years. So I'm going to change that so we have years and births here, and we've got years and births over at the function. Now, we already have the years and the number of births list, so we can zip them together. All we need to do then is to calculate the running average. So we can do this by summing up all of the births in the relevant years by the number of years, but we need some way to track or count the number of years. Now, anytime we require a count in Python when iterating over an iterable, think of the enumerate function. So let's use result to store our list of tuples. So result will be our list. And to calculate the average, we'll first need to sum the values. So let's initialize sum to 0. Now, there's already a built-in function called sum, so I'm going to call my variable sum underscore. When using enumerate, start counting from 1 rather than the default 0. So for index, and then the year and the birth in enumerate, and then we want to zip together the years and the births, and we want to use our start equal to 1. Now, what we want to do then is to add up the births for each year. So our sum variable is going to add up the births. This way, we can calculate the running average as the sum divided by the number of years, or the sum divided by the index. So we're almost there. So let's create our tuple. So we've got the year, the birth, and we have the sum divided by the index, which gives us the running average. Now this has the year, births, and the running average. The docstring tells us that the running average needs to be an integer, so let's use the round function. So we round up the running average, and let's add this to our list. So our list is called result, so result.append, and we've added that tuple to our list. And all we need to do then is to return this list. So return result. I think I'm missing a parentheses here, so I'm just going to add another bracket. Right, now let's go ahead and run our solution against the tests and see what we get. So PyTest, and I'm in the exercise folder, so challenge, tests, and then test, zip enumerate. So we can ignore the warning message. You can see that we've got one passed. So this passed the test. So that's the end of this challenge. Now, if you have another solution that passes the test, that's absolutely fine. Your solution doesn't have to be identical to mine. Just so you know, an iterable is anything you can loop over with a for loop, and a sequence is a subset of iterables, but they have a length, an index, and you can slice them. Examples of sequences are strings, lists, and tuples, and examples of things that are iterables but not sequences are dictionaries and sets. So when reversing things in Python, we're normally referring to reversing sequences. Every list in Python has a built-in reverse method, so you can reverse the contents of the list objects in place. Now, what we mean by in place is that it will directly modify the original list object. Let's copy the countries list from the reversed.py file, and let's take a look at the REPL. Now I can reverse this using the reverse function. Now you can see that the countries have been modified in place. The potential downside is that reversing a list in this way is that you've lost your original ordering. Of course, you could always reverse again to get the original order. Another way to reverse Python's list objects is to use slicing. So I'll take the reversed countries and put them back in the original order. This isn't a reference to alphabetical ordering, it's just the order the objects were in the list. So just as a reminder, we have them as countries there, and I'm just going to reverse slice them in this way. Just so you know, reversing a list this way takes up more memory compared to an in-place reversal because it creates a copy of the list. The biggest problem with the slicing notation is that it isn't very intuitive. If you were new to Python, you could probably guess what the reverse method does. The slicing notation isn't as obvious. So reversed doesn't reverse a list in place, nor does it create a copy. It returns an iterator of the reversed items instead. So this isn't new. We've seen iterators before in zip and enumerate. They both return an iterator object. So if I wanted to loop through the countries using a for loop, I could do the following. So this is my countries list. And so for country in reversed countries, and I can just print out the country. And what if I wanted to create a reversed copy of this list? Well, I could create, so let's see what countries first looks like. And now let's create a reversed copy of this, and let me call that reversed countries. So reversed countries is a list of reversed countries. And so we can take a look at what reversed countries has. And you can see that it's reversed the items in that list. Now, I think the final solution is the best. It doesn't modify the original list, and it's a solution that scales well. So if you're writing code for a solution where you're dealing with millions of items of data, then reversed allows you to access the items only when they're needed because you're using an iterator. The other solutions are not as memory efficient. Now let me clear my screen. We've spoken a lot about lists that are mutable sequences. So how do we reverse immutable sequences such as tuples and strings? So just so you know, an immutable object is one that after you create the object and assign some values to it, you can't modify those values. So since strings and tuples are immutable, they don't have a reverse method. This is because the reverse method updates the original object. So let me show you an example in the Python REPL. So if we take the string Japan as an example, and I try and reverse it using the reverse method, you can see that no attribute reverse exists. Now, if we create a tuple from the countries list, and let me just copy the countries across. So now if I go ahead and reverse the tuples list, so tuple countries, and try and reverse this, you can see that no reverse attribute exists. So if you want to reverse strings or tuples, use reversed or slices. So I can easily reverse one of the country names. So let's use Japan again, using slices. And let me demonstrate reversing a tuple using reversed. So we have tuple of countries. And so for country in reversed, and I use the tuple and the countries, I can print this out in reverse order. Now, before we end, let me review the 3 ways to reverse a sequence in Python. So reverse changes a mutable sequence, so that's things like lists in place, but they're not available for immutable sequences, so that's things like strings and tuples. Slicing creates a reversed copy of a sequence, so it's the fastest of the 3, but it makes a copy of the sequence. So there might be some memory considerations if you need to reverse millions of items, and it works on both mutable and immutable sequences. And finally, reversed returns a reverse iterator. The good news is it scales well to millions of items, and it works for both mutable and immutable sequences. And that is Python's reversed function. In this challenge, determine if a word or a sentence of words is a palindrome. So let's define a palindrome as a word, phrase, number, or sequence of words that reads the same backwards as forwards. Now, punctuation and spaces between the words or lettering is allowed. Now, I've written a helper function called remove punctuation that removes punctuation and spaces to help you out. You don't have to use it, you can create your own solution. Now, let me show you how remove punctuation works in the Python REPL. Now, let me just copy this across and the RE module. And so I can enter remove punctuation. This should return a string with no punctuation or spaces. And there you have it. Now, using this helper function, create your own function isPalindrome to determine if a word or several words are a palindrome. Now, you can use PyTest again if you want, or completely ignore it. Now, if you're going to use PyTest, let me show you the path to that file. So I'm in the exercise folder. So PyTest, challenge tests, and then we want to head over to the test reverse challenge py file. So use the reverse underscore challenge.py as your starting point. So that's this file. And this challenge should take you between 5 to 10 minutes. So if we take a word and reverse it, and if it's equal to the original word, then we know that this is a palindrome. Now, if you've come to Python from another language, your first choice might be to work your way character by character and compare the strings in that way. Or you could use Python's reversed function. So let's head over to the REPL. Now let's use the reversed function. So I'm going to define words as the word challenge, and reversed words gives me a reversed object. So I can collect the letters up in this way by using the join function. So if I have 2 quotes, join, and you can see that I've got the word challenge in reverse order. So let me use this in my function. Just copy that across. And let's head over to our isPalindrome function. So let me just copy that across again. And let's call this reversed words. The next thing we want to do is to pass this to the remove punctuation function. So if I go remove punctuation, and if the words is equal to remove punctuation of the reversed words, I'm almost there. Now, we also want to make sure that all of the characters are either upper or lowercase. Now, this is because the two strings of words could be the reverse of each other, except one of them has a mix of lower and uppercase characters. So let's just go with lowercase. So I'm going to make sure that both of these are lowercase. So words is lower and reversed words is also lower. And we can return this, and we're done. So return, and I'm going to save this. And let's confirm this passes all of our tests. So just going to head back here, get out of the REPL. Now I'm in the exercise folder. So PyTest, challenges, it's in the test folder, and I want to test reversed challenge. You can see that we've got 2 passed. You can ignore the warnings. And since it passes all the tests, we've completed this challenge. Min and max work in the way we would expect. So max returns the largest item in an iterable or the largest of 2 or more arguments. Let's take a look at an example in the REPL. So I can enter a whole load of random numbers, and max will give me the largest number. So 5, 6, 3, 4, and we get the expected output of 6. I can enter an iterable such as a list. So now I'm going to copy the countries and their associated populations from the min-max file in the exercises folder and just paste it into the REPL. Now the populations use underscore as a visual separator for numbers. In Python, we couldn't use commas because 1 million with commas in Python would be a tuple. The largest population we have here is 198 million. So if I do a max of the population, we see we get 198 million. And as you can imagine, the min function does exactly what it says on the tin. It returns the smallest item in an iterable or the smallest of 2 or more arguments. If you applied min to the countries list, as all the items are string, it would return the smallest item based on alphabetical ordering. So for the countries list, Japan is returned because if you look at all of the items in alphabetical ordering, Japan is the lowest. Now with these 2 lists, if we wanted to determine which country has the lowest population, we need to first find the lowest population in the population list and then visually find the corresponding country. Is there a better way of finding the country with the lowest population using min? Well, the first thing we can do is to zip the countries and the population. This means we're now working with tuples. So I could do a list of my zipping of the countries and the population. Now, tuple comparison works the same way as string comparison. We have 2 tuples as an example, one with the string Nepal and the other Niger and their associated populations. So we start from the left, compare the corresponding items of each tuple, and if they're the same, move on to the next item. Both have the same letter uppercase N, so we move on to the next character. Now you can see that the letter E from Nepal is alphabetically lower than the letter I from Niger. If one of the corresponding items of a tuple is less than the other, then the entire tuple is less than the other. So we would say that the tuple with the string Nepal is less than the tuple with the string Niger. Let's take another example, this time with Niger and Nigeria. If the corresponding items of one tuple are the same as another tuple, but there are no further items, then the shorter tuple is less than the other. In this case, Niger is a substring of Nigeria, and so the tuple with the string of Niger is less than the tuple with the string Nigeria. And finally, let's look at an example where we compare the tuple Nepal with another tuple Nepal with the same population details. If all the corresponding items of a tuple are equal, then the tuples are equal. You might have noticed that in all of the examples where we've done tuple comparison between 2 countries, we've only compared the names of the countries alphabetically and decided that one is less than the other. We haven't even got as far as comparing the populations, which is what we were trying to do in the first place. This means that if I do the min and I zip together the countries and the populations, This returns Japan because Japan has the lowest string alphabetically, starting with JA. So to get the min function to compare the populations, we'll need to use min's keyword key. Now, one way we can do that is to define a function called getPopulation that when we provide it with a tuple, it will return the population. So define getPopulation, and it takes in as an argument a pair. It then splits that out into the population and the country, and then we just want to return the population. So now when we use min, but this time using the key keyword argument, and we provide the getPopulation function as our argument. I now include getPopulation. And we see that Jordan has the lowest population with 10 million. Now, another way to achieve this is by using a lambda function instead of the getPopulation function. Now, if you look at getPopulation, all we're doing is returning the second part of the tuple. So we can rewrite that using a lambda function. So my lambda function is defined here. So lambda x, and I just want to return the second item. And because Python is 0 indexed, x1 will return the second item. And we get the same result. Now, another way to solve this problem would have been knowing that how tuple comparison works, we use the zip function and provide the population first and then the country name. This way, the tuple is created that has the population as the first item, and now that the populations are compared first, we get the country with the lowest population. And that is Python's min and max function. In this challenge, there are two functions you need to complete. Words are only given a score if they exist in the Scrabble dictionary. I've provided a text dictionary in the exercise files. So this isn't the official Scrabble dictionary, it's just a dictionary with several thousand English words. Now, if the words don't exist in the dictionary, they're given a score of 0. I've provided a helper function called getScrabbleDictionary that returns a list of the words in the Scrabble dictionary. So what you need to do is to complete the function scoreWord, which will return the score of the word using the Python dictionary letter scores. So the letter A has a score of 1, the letter B has a score of 3, and so on. The second part of this challenge is given a sentence, return the word in the sentence with the largest score. So a sentence will have punctuations, so you can use the remove punctuation helper function when working with the sentences to determine the score of words. Now, as always, you can use the test file in the test directory, or you can ignore it completely. If you decide to use the test file, then this is what you'll do. So I'm in the exercise folders at the moment. So pytest, challenge, the tests folder, and then test minmaxchallenge.py. So go ahead and use the minmaxchallenge.py as your starting point. This challenge should take you between 5 and 10 minutes. Let's head over to the minmaxchallenge.py file. Now we want to call getScrabbleDictionary because it gives us all the words in our Scrabble dictionary. So let's copy this across and head over to our REPL. So let's do a call to getScrabbleDictionary. You can see that all the words seem to be in alphabetical order and are in uppercase. Now let's go ahead and update the scoreWord function first in our min-max challenge. So I'm going to replace this line. Now, one of the first things I like to do is if I'm doing a lookup, I'd rather do it using sets than a list. This is because under the hood, sets use hash tables, and the performance with sets is significantly better than with lists. So let me call that dictionary. And we do our call to the getScrabbleDictionary, and it's returned into a set. Now, we will only score words if the word is in the dictionary. Now, since all the words in our dictionary is in uppercase, we want to do a lookup on words that have been converted to uppercase. So if word upper in dictionary. Now let's work our way. So for each character in the word, so that's for car in word, and let's look up the letter scores Python dictionary. Now, one way to do this is to use the get method with the Python dictionary. Now, this way, if the character doesn't exist, we can set the score to 0. So letterscores.get, and we're going to do a lookup for car, otherwise it gets a value of 0 for car in Word. Now, since the letter score is only in lowercase, we want to make sure that we pass the lowercase of the car to the letter score. So let me change car to car.lower. And then we want to add up all of the scores so that we can pass this to the sum function. So return, and we sum this up. And finally, if the word isn't in the Scrabble dictionary, we just want to return a score of 0. So return 0 otherwise. So let's go ahead and test this out. So I'm just going to get out of the REPL, clear my screen. So I'm in the challenges directory. So if I go ahead and do a PyTest, tests, and then test min-max challenge, you can see that 3 have failed and 3 have passed our tests. Now you can see that the ones that have failed have the word failed on our screen, and we have the function names. So let's head over to our test min-max challenge file. Now you can see that test word largest score, test word with punctuation, and test made up sentence are all failures related to the get word largest score. And the reason that they failed is because we haven't implemented that function yet. So the functions that we have created, which is score word, works. Let's now work on the get word largest score function. So I'll just go ahead and replace this line. Now let's think a little bit about how we want to go about finding the largest scoring word in a sentence. So we've already got score word that determines the score for a word. Now if you can somehow chunk our sentence into words, we can reuse that score word function. So to get the largest scoring word, we can use the max function. So let's start by returning the max function. And to chunk our sentence into words, we can use the split function. So this way, the white spaces between each word is a separator, and we'll return a list of words. So let's put this into a list comprehension. So word for word in sentence, and we want to split this. And we've already got a function that calculates the score for a word. So we've implemented that earlier in the video. So let's use score word using the keyword argument. So score word here as our keyword argument. And we're almost done. Now this isn't quite right because by default, the split function will only separate out words by white spaces. If a word is followed by punctuation, say you have a word and then a comma or an exclamation mark, then you won't be able to find that in the dictionary and you'll get a score of 0. So we want to remove punctuations. So we can use the helper function to do that. So we pass in our word to the remove punctuation function. So remove punctuation. And we should be done here. So let me save this and let's rerun our test. We've got one warning message which we can ignore, and we've got 6 passed tests, and so that means we've passed all the tests, and that's the end of this challenge. Like the min and max, all of the values that you give to sorted need to be orderable. This time, let's use classes for the countries and population. So I'm just going to grab the code from sorted.py. Just going to make a little bit more space for my REPL. So we define a name and population in our init method and a repr method so that we can display the details. We'll then define a country list that has all the countries with their associated populations. I've added 2 new countries, Taiwan, which has the same population figures as Niger, and Portugal, which has the same population numbers as Jordan. And like min and max, we have the key parameter that we can use. Now, if I want to sort the country list by the population, I could write a short function to get the details. Since it's relatively straightforward, let's just use a lambda function instead. So sorted, I use the country list and use the keyword parameter with the lambda function, so lambda x, and I just want to get the details back of the population. So that's x dot population. Now, if you want to sort in decreasing order of population, we have 2 options. You can use the reverse keyword. So I just add reverse equals true. Alternatively, you can append a minus sign to the population in the sorted function. So I remove reverse, and I just add a minus sign beside x.population. And we get the same result. Now, what if we wanted to sort by decreasing order of population, but we wanted the names of the countries to be sorted in increasing alphabetical order? Here you can see that Taiwan and Niger have the same population figures, but Taiwan appears before Niger, and Jordan and Portugal have the same figures, but Portugal appears before Jordan. So let's sort in decreasing order of population, but increasing alphabetical order. So you can use a tuple. So x minus x.population and x.name. You can see that both Taiwan and Niger have the same population, but this time Niger is before Taiwan, and similarly, Jordan and Portugal have the same figures, but now Jordan appears before Portugal. You can't sort in decreasing alphabetical order using a minus. Instead, you want to use the reverse keyword, sorting in decreasing order of the population and in decreasing alphabetical order. And so we say reverse equals true. Now let's take a look at another example. Let me go ahead and clear the REPL. And let me grab the ISO details from the sorted.py file. Many times, the data you have might be mangled or not quite in the format you need it. Here, the string ISO is appended to each of the populations. So how can we still sort by population? One way to go about this is to try and find some way to ignore the ISO and then pass it to the sorted function. Let's write a function getPopulation to return just the population from each tuple. So def getPopulation, we take as an input a pair. We split that out into the country and population. And we then want to return the population to the sorted function, but we need to ignore the first three characters. So population. And since Python string indexes start from 0, we want to return from index number 3 onwards. So let's go ahead and do a sorted. We provide as input the ISO and key equals getPopulation. And we don't get the results we expect. We have Nepal having the largest population, which we know isn't true. The reason we have this problem is that the sorted function treats the populations as strings. This means all of the ones come before the twos and so on. So we need to modify our getPopulation function so that the population is returned as an integer. So let's just do this by casting the population as an integer. So let me modify my getPopulation. And this time I'm going to cast it with an integer. And let's pass this through to the sorted function again. And we get the expected results. And that is Python's sorted function. In this challenge, you're given a list of country names and populations. Unfortunately, because of some data errors, you can see that there's the string ISO tagged onto the end of each country's population. So go ahead to sorted_challenge.py and update the getSorted function. So return the country list so that it is sorted first by population and then alphabetically by country name. Now, as always, you can use the test file in the test directory, or you can ignore it completely. Now, if you decide to use the test file, this is what you'll do. So I'm currently in the exercise folder. So pytest, challenges, tests, and test sorted challenge. So go ahead and update the getSorted function using the sorted_challenge.py as your starting point. This challenge should take you between 5 and 10 minutes. Let's look at two solutions for this challenge. In the first solution, we'll use an alternate to tuples with the sorted function. And finally, we'll look at a tuples-based approach with the sorted function. So let's break this problem down into a couple of steps. So in order to sort by the population and then the country name, let's first sort by the country name, which is the secondary requirement, and then go ahead and sort by the population. Now we do this because if we have two countries with the same population, then they will already be sorted by country name when it comes to us sorting by the population. So let's head over to the REPL and take a look at ordering by country name. So I'm just going to copy across this code with our class country and the country list. Now let's sort the country list. So sorted country list, and then our keyword parameter, and then lambda x, and we're going to be sorting by the country name. Yeah, I've just got a typo there, so I'm just going to change that to key. Now, this is an unexpected ordering because although we're sorting alphabetically by country name, the first two entries, Portugal and Taiwan, are before the third and fourth entry, Japan and Jordan. Now, the reason for this is because the Unicode code points that are used to represent the characters. These Unicode code points have a lower value for uppercase letters than lowercase letters. So let me show you what I mean by this in the Python REPL. So let me go ahead and clear my screen. So if we import the string module, now string.ascii lowercase gives me the English alphabet in lowercase letters, and similarly string.ascii uppercase will give me the uppercase letters. So I want to work my way through each of the characters. So let me go ahead and use a list comprehension. So for car in string ASCII lowercase values, let me go ahead and print the Unicode code point values, and I can get that using the ord function. So ord car for car in the string ASCII lowercase. And let me do the same thing for the uppercase values. And you can see that the ASCII uppercase letters have a lower number than the ASCII lowercase letters. This means if we sort by letters, the uppercase letters will always be displayed before the lowercase letters, and that's exactly what we saw earlier. So if we want to sort by the country name, let's ignore the case of the letter, and we can do that by comparing them all based on their lowercase values. So let's go ahead and update our getSorted function. So let me replace line 24. So sorted, we want to use the country list and our key keyword parameter, and then lambda x. And we want to get the country name, but we want the lowercase value of this. So let's store this in the variable result. Now let's go ahead and sort by the population. Let's create a helper function to return the population. So define the getPopulation. We're going to take in as argument a pair. Now we know that the string ISO is appended to the end of each of the population figures. So let's separate out the pair into the country name and the population. So country and population. And so we want to take the pair name and the pair population. So now we just want to return the population. Now we can't just pick the first 8 digits of the number because both Japan and Nigeria's population is over 100 million, and so that's 9 digits. We can still go ahead and do slicing though, but this time ignore the last 3 characters of the population. And so we can do that by adding a -3 at the end of this, and we want to return an integer cast of the population. This will ensure that when we do any sorting, it's going to be sorting based on the integer values rather than the string values. Now let's head back to our getSorted function. So we've done the first pass of the sort using results. So let's reuse result. So sorted result, and this time we use the keyword parameter, and we will use our function getPopulation. So let's go ahead and return the sorted item. So return sorted result with the function getPopulation. So let's save this and let's run our tests on our getSorted function. So PyTest, I'm in the exercise folder, so challenge, tests, and then the test sorted file. So that's test sorted challenge.py. You can see that we've got one warning and that this has passed all our tests. Now, just so you know, you can also do this as a one-liner using a lambda function and a tuple. So I'm going to comment out my previous code.
So I'm going to start off with the country list. So I want to return the sorted country list. So I use key equals lambda x. And then I want to create my tuple, so sorting by population. So let me just copy that from the get population file. Now remember that this is a tuple, so this is going to be the first entry of our tuple, but we don't want just population, we actually need x.population because we're going to be accessing the population from the class. So that's x.population. And the next part of the tuple is to sort by the country name. So I can get that from result. So that marks the end of my tuple. And that's the end of the sorted function. And let's go ahead and test this. So I just rerun the PyTest. And you can see that this has also passed all our tests. And so that's the end of this challenge.